Before that, let me introduce myself. I am Pavan Kumar Reddy, and I have almost like 8 years of experience, out of which like from past 5 years I'm doing a corporate trainings in India, and pastly I was into Java. From past two years, 1.5 years, 2 years, I'm into Hadoop technology. I've been taking like lots of batches in daytime, in the evening time, almost like 60 batches I've taken. And lots of companies also have trained if in India. Right, so that's me. Let's start our discussion. All right, so I have a slide here. Here, I just want to show that how much data is generating every day. Right, so there are approximately 2 zettabytes of data, which is close to 1 billion TB. Right. The moment you see this type of data, two things comes into consideration. Right. When you see 1 billion TB, right, so you will think about like how I can store them and how I can process them. Right. So processing is nothing but just doing calculation. If I want to do some calculation on top of the data, how I can do it. Right. So two things is bottleneck. Earlier, all my computing services, as like all my previous programming languages, are able to process only few terabytes of data. Now my requirement is I want to process 1 billion terabytes. It's huge one. Right. Two things comes into my mind as. Give me 1 second. So one is how I can store them and how I can process them. Alright. So because my traditional system can process up to few terabytes of data. But here I have to deal with petabytes of data, zettabytes of data. That's huge. Alright. And you have one popular example of Facebook. Alright. Facebook hosts lots of photos, lots of people in in this social networking site, right? So there are like almost like 240 billion photos with 350 million people adding every day, and there are daily almost like 2.7 million likes and 2.5 billion content sharing. So they also have a 1-2 problem again, right? How to store incoming data, whatever they are getting on the daily basis. And if I want to do some calculation, if I want to do some analytics, or if I want to apply some math on top of existing data, how do I need to process? I don't have any processing engine, right? Same problem here, storing and processing, right? So there are like 15 millions. Apart from this, like there are 15 million smart meters, which is generating data at the rate of generating 3 GB data. Right? Think about 1 minute, right? 60 seconds. 180 GB. Alright, so 1 minute it is generating 180 GB. Think about 1 hour. Alright, this data which is coming, which is hitting to source is very huge. Alright, so you have again these two problems: how I need to store them and how I need to process them. Right. So another example we have here is whatever the recommendation which is providing by Google. Right, so Google provides some recommendation over on site. Like when you search for any other thing, you will get some recommendation from the Google. Like if you're purchasing one computer and you didn't purchase it, you will get lots of ads from Google. That is nothing but suggestion. What they will check is they will check your log files and they will find it out. Oh, you want to buy this computer. All right, let me give you a best price out of it. So you'll be getting a lots of suggestion from the Google. All right, so how we need to perform this? Because if I see entire internet, it's gonna be huge data. Right? How I need to find it out? How I need to work it out? How I need to store this? And how I can know that you are interested to buy the computer, and how I can show the result to you, how I can show recommendation to you, because they have to pass through trillion pages, which is behind the scene, And you need to have some indexing and page ranking kind of mechanism to do some processing, right? So every time, like in this slide of interesting facts, what we are seeing here is problem area is storing and processing, right? I need to have another good mechanism which can store huge amount of data and which can do some calculation on top of stored data, right? We need some good processing techniques, right? So let's see that how we can overcome these problems. All right, so any company, be it be any company, any enterprise, there are there are two important things. Take some XYZ company, right? So enterprise, take an enterprise here, all right? So any XYZ company, like important thing is data, right? So whatever software programming you're doing, whatever be the technology name, you name any technology, what actually depends on? It actually depends on your data, right? Any enterprise design, development, creation, you're providing a solution, it's completely based upon the data, all right? So out of which data is very important, right? So if you want to store this data, what you required? You required hard disk, all right? You required systems, right? So another important component is systems. I have systems now, right? In order to store this data, what you required? You required systems. So you need to know about system because you have to store huge amount of data, right? So in one system, I cannot store all together. So we require multiple systems, all right? So we will learn about distributed systems as well. All right, so to work with data, to work with systems, what you required? You required a person like us, all right? You required a software developer like us, right? Since we know about ourselves, I'm not discussing about the human resource. All right, HR part, I'm not discussing. We're going to discuss deeply about data and systems, right? So the data is like anything, any enterprise offer, data-driven solution to the customer or to the end user. So you need to know about the data, all right? So you have a lot of data scientists to understand your data itself, all right? Specific job role they have to understand the data. All right, so you need to understand all the property of the data. Then only you can analyze, and then you can do some processing on top of your data. Right. So first we will cover data part, and let's see where exactly your Hadoop fits into it. We will learn about data lifecycle management, and we'll see where like Hadoop fits into it. All right. Then later on we'll go to your systems. So we have seen the two components, important components, data and systems. All right. Out of which data is very important, so you need to understand data lifecycle management. Data lifecycle. And here you need to take into consideration like how Hadoop fits into it. Data lifecycle management. Right. Now you have a requirement. Think that you have a use case. Your data is there in some like many systems. You cannot hold entire data into one system, right? You have your data, some data inside this data source 1. You have some data inside this data source 2. You have some data inside this data source 3. Right? Think that this data source 1, think that this data source 1 is RDBMS data. Think that, guys, I will request you to mute yourself. If you have any questions, you can unmute, you can ask. All right. So in attendees list, you have when you like When you open attendees list, you will see a mute and unmute option. Right? You can mute yourself, and if you have any questions, you can ask anytime. All right. So now we were discussing, like, I have my data inside RDBMS. I have my data inside some application server. Right? My application is hosted it, and data is generating from here. All right. I have some data in some XYZ data source, some B2B mainframe, B2B SAP system, some data sources. Take it as XYZ data source. Right. I have my data in RDBMS, application server, some XYZ data sources. Now, my requirement is I want to do some calculation on top of it. I want to do some processing. Right. If I want to process, I cannot process in RDBMS data alone. Right. I want to process all together. Right. On entire data, if I do some analytics, I will get aggregated result. Right. So first job is, and first step of your data lifecycle management is, what you need to have here is, you need to capture all the data from different data sources. All right, be it be RDBMS. All right, you need to have a mechanism which can capture your data from RDBMS. You need to have a mechanism which can capture data from application server. You need to have a mechanism which will capture your data from XYZ data sources. Right. So first phase is capturing phase. Right. Once data is captured, you're required to store your data. Right. You need to store your data. So what do you need to do? Right. You need to have a storing mechanism. That is next phase. Storing. Okay. So for storing, what you require a file system like mechanism. Right. You require an operating system or file system like mechanism. I have a file system here. So we require a file system like mechanism. Since I cannot store entire data into one single file system, I required multiple computers. You cannot store entire thing in one computer, right? So you require multiple computers. So I'm dependent on DFS, distributed file system. So I will make a cluster of computers, right? Many computers to store my data. We'll see how we will store our data in our system part. Right. So now, once the data is captured, it has to be stored in the centralized repository for storing mechanism. This is my second stage. All right. So now, all my data from the different data sources are stored in one centralized place. All I have to do here is, I need to do some calculation on top of my DFS. All right. So what I have to do for calculation, any calculation if you want to do, you require to know little programming language. Okay. You require a programming language which will compute on top of your distributed file system. All right. So once computation is applied on this stored data, you will get some results. Okay, you will get some results that you can report into any reporting tool. Any reporting tool, you can report it. Or you can integrate with any BI, business intelligence tool. Or you can integrate with simple Excel. Right. So you require a programming language because your data is stored in multiple computers. Your Java doesn't work good. So you require a new programming language. Right. So here, this phase, you can call it as process. Right. This phase captures, storing, processing, and reporting. Programming language, you require a new programming language called MapReduce. There is a programming language with Hadoop. All right. So it's called MapReduce. You have a storage called HDFS, Hadoop Distributed File System. Till now, what we have seen here is we have two issues, right? Where in first slide you have seen like you have storage issue and process issue. So how we are overcoming here? We are overcoming here with the help of HDFS and with the help of MapReduce. All right. So MapReduce is written in Java. All right. So the people who doesn't know Java, Facebook has introduced a technology called Hive. With the help of Hive, you can write your code in normal SQL language, and your Hadoop framework will convert them into a MapReduce programming. Right, that job's gonna be do automatic. Right, if you don't know SQL also, there is a plain English like kind of scripting language called Pig. All right, anybody can learn this language within no time. Now, with the help of Pig, you can do some calculation on top of your HDFS. All right. So once you execute the Pig command, all right, it's gonna convert them into a MapReduce job, and you will get some result out of it. Right. This is your complete phase altogether. So how we are collecting, how we are capturing the data, how we are storing them, how we are processing them, how we are reporting them. All right. So apart from this, you have some tools available. Any questions, guys?
No, that's fine now.
Cool. All right. So stop me if you have any questions or if you feel like I'm a little fast, or you can stop me. If
Hello,
you're not,
Paul.
yeah.
Yeah, I want to
Yes.
say one thing. You sound really good, man. You sound really good, and it's so easy to understand you. And I'm so
Thank
happy
you.
to hear you, man.
Thank you very much. That's a nice compliment. All right. Thanks, Anuj. All right. So we required some tools. We required some tools to capture our data. All right. So since I need to capture my data from RDBMS to HDFS, so what I have to do here is I required some tools. I required Scoop. Right? There is a tool called Scoop. With the help of this tool called Scoop, we can capture our data from data to HDFS. All right. So if I want to capture my data from application server, just like Tomcat or any other application server where your application is hosted, all right, your Facebook is hosted in some application server. If you want to get your data from your application server, you have a tool called Flume. Okay. With the help of Flume, what you can do here is you can capture your data from application server to HDFS. All right. If you have some XYZ data sources, be it be mainframe, be it be SAP system, be it be anything, right? You have Java HDFS API. All right. If you are good at this Java HDFS API, you can do like don't require this tool also. This is like for your convenience. They have designed this program to make things easier. Right. So, all right, all these technologies, what it's doing here is it's making your Hadoop easier. So Hadoop does have two components. One is storing and processing. Right. Storing, we have a HDFS, and for processing, I have MapReduce. Right. So if you're learning Hadoop, there are two components altogether. Right, you're gonna learn about HDFS, that is storage, file system, administration. You're gonna learn in the HDFS, and processing part, how to process, how to write analytics, how to write jobs. You will learn in MapReduce. Right. So apart from this, you're gonna learn Scoop, Flume, all other technologies which is related to Hadoop in this course, and you have, like if you want to store this data into some databases, you require some database kind of mechanism, right? But my traditional system, my traditional database, I'm not capable to store any kind of data, right? My data has to be structured. Then only I can store my data. But my problem is from Hadoop, it's not guaranteed that you will get a structured data. Right, so I need a mechanism where I can store my unstructured data as well. Right. where I have requirement to store my unstructured data as well. So what I have to do, all right? So I have an option called NoSQL databases. Okay? So NoSQL databases. So this type of NoSQL databases, you can call it as it will allow you to persist your data from Hadoop framework. Like if you want to store your data from Hadoop to some database kind of thing, you can use NoSQL databases, right? They are like more advantages. Like you can do random access, you can do a lot of things that we will learn in the NoSQL part. We're going to learn uh, about NoSQL database. Important one is HBase. Apart from HBase, HBase is NoSQL database. You have some other databases as well. What are they? You have Cassandra. This is by Facebook. You have Voldemort. Voldemort. That is by LinkedIn. You have CouchDB from some XYZ company. All right. So you have so many. You have DynamoDB. All right. So you have so many NoSQL databases. The main perspective of NoSQL databases is just to persist your Hadoop data so that you can have a random access. Right? We're going to learn random access and sequential access in detail in our coming sessions. But for now, just think that it is a kind of storage. Since I cannot use my RDBMS because my data can be unstructured, I require a special kind of database. That is not only SQL database. And we have some example in not only SQL databases. We have HBase, we have Cassandra, we have Voldemort, we have CouchDB, we have MongoDB. There are a lot of implementation coming. You can you can list out. There are like 20. All right. All right. So that's about the data lifecycle management. All right. That's about the data lifecycle management. Now you know that where my Hadoop fits into. My Hadoop consists of two components, HDFS and programming language. All right. So this is your entire framework. All right. So now let's go further. All right. So I'm a DB guy. I have some questions inside my I have some question in my screen. All right. I have a guy who's proficient in only SQL database languages, and he wants to work. He wants to work with database. He wants to work with databases. So what I have, sorry, if he wants to work with Hadoop, all right, what he has to do? He has some big data issue. So he can always work with the technology called Hive and HBase. With the help of Hive and HBase, what he can do here, he can write your code in normal SQL language, and your Hadoop interpreter will convert them into a MapReduce job.
Okay.
Right? And you have HBase to store the data, to persist the data. If you want to do some calculus, if you want to persist your data into NoSQL, you can use NoSQL database. One of the implementation is HBase. And one C++ guy with us. All right. So Hadoop is written in Java, and I'm purely C++ background. Can I write or can I work with Hadoop? Does it solve my big data issues? Yes. You have an implementation called Hadoop pipes. With the help of this Hadoop pipes implementation or API, you can write your code in C++ language, and your Hadoop interpreter will convert them into a MapReduce.
Okay.
All right.
Okay.
All right. That is one of the feasible things you have. You need not to learn other technology here. Right. A person is a statistician. He knows only R, and he wants to write a MapReduce jobs. How he can? So Hadoop does provide a package called RHIPE package. With the help of this package, you can write your code in R. R is nothing but one of the statistic tools, right? So statistician doesn't know the programming language, so for them, they have given this RHIP package? Well, there are like so many languages in the world. Right? You have Python, Scala, Ruby, PHP, .NET. But from Java, there are a lot of uh, pro- programming languages available for and different kind of programmers available. Does Hadoop support all of this? Yes, Hadoop support all of this with Hadoop Streaming API. Right? So in slide, what I'm going to say here is Hadoop is not language specific or it's not language dependent. Right? All you have to do here is you have to write your code in your language, whatever you know. Right? If you don't know also, no problem. We have a language called Pig. It's simple like English language. Right? You can learn that language from the scratch. It's just very simple language. Right? You can write your code in your specific language and my Hadoop will convert them into a MapReduce job. Right? So it does provide a high level abstraction on top of your MapReduce job. All right, so let me quickly discuss like what are my data sources and what are my data properties. I think we have time constraint. No problem. Like we can discuss the data sources and data properties. All right. So as a data scientist, or as a developer of big data, you have to take into consideration, like you have to understand your data perfectly. Right? You need to understand from where your data is coming from. Right? Before doing any job, first job of yours is you need to understand your data. Like how you will understand your data. If you know the data properties, then only you can understand, like you can analyze your data. Right? So first you need to find it out from where my data is coming from. Whether it's coming from machine or whether it is generated by a users. Right? Whether it's generated by users or whether it's machine is generating. Take an example of machine specific generated data. Right? Any log files, any log files which is generating by your application server, any files which is generating by your machines is nothing but your machine specific generated data. You have examples, server logs, you have example RFID, you have example of sensors, scanners, crawlers, mail logs, so many things. You have user generated like transactions. You do some transaction, it is user specific transaction. You chat with your friends in Facebook, all right, that is data is generated by you. That is the reason I call it as user generated data. Right? So you need to understand this. And you need to understand what type of structure, what types of data it is. Right? Whether it is structured, whether it is unstructured, whether it is semi-structured, you should have to categorize. Let's learn what is structure, what is semi-structured, what is unstructured. Right. So one of the important thing we know structured data from very long time. Everything in the form of rows and columns, you can call it as structured. Oops. Right, everything in the form of rows and columns. Everything is in the form of rows and columns stores in the system. You can call it as a structured database. Right? So you know this. To access database, you require SQL language. You know from your childhood. Right? So semi-structured. You have very good mechanism available for structure. You have evenly better mechanism available for semi-structured data. You have a Java processing system with the help of like, what are semi-structured data? Your XML files, your JavaScript object notation files, all these files are like semi-structured. They are not in the form of rows and columns, but they have some structures, all right? Some inbuilt structure they have. Right, so if I want to read those semi-structured files, I have some parsers with me. Right, if I want to read XML files, I can process them with Java, with using some SAX parser or DOM parser. I can do it. All right, but what about the unstructured data? So if your data is not structured, if your data is not semi-structured, your data has to be unstructured. Any flat files, you can call it as unstructured, or you can say which does not have any structure at all, you can call it as unstructured. Any data which is coming from web, any data, whatever you're typing, whatever you're chatting with your friend, those are nothing but your unstructured data, because while you're chatting with your friends, you don't maintain index, you don't maintain anything.